Blockchain is the technology that underpins the peer-to-peer system of the famous cryptocurrency Bitcoin. Essentially, it is a digital distributed ledger of transactions. Commerce has relied on ledgers for centuries to record assets such as money and property. Central authorities have needed centralized ledgers and back offices to record assets and consolidate data between transacting institutions. The centralized ledger is kept by the central authority as the central source. By contrast, a distributed ledger, like blockchain, works like this. The word distributed means that the ledger is held by and shared with all transacting participants direct in real time. Any changes to the ledger are reflected digitally in all copies in minutes or even seconds. The accuracy and security of distributed ledgers records are maintained cryptographically. Entries can be updated by one, some, or all participants, depending on the rules agreed by the network. Distributed ledgers may therefore be more efficient and potentially cheaper than traditional centralized alternatives. Moreover, they can allow assets to pass from one party to another without the need for a trusted third party. The Bitcoin blockchain provides a good example of how transactions are verified using a distributed ledger. Every node or computer maintains a copy of the ledger which is hosted across a distributed network. Every individual node then competes to add the next block to the chain. When a transaction takes place between parties, in this case, when Bitcoin is transferred from one party to another, that transaction is broadcast to all the nodes on the network. Each node then collects these transactions into packages. This is done by creating a hash of each transaction. A hash is a string of code which acts as a unique identifier. These hashes are then paired, hashed again, paired again, and so forth until only one hash remains. This structure is known as a Merkle tree, and the final hash is known as the Merkle root. The Merkle root is then stored in the block header. Each node then works on hashing the block header. This is harder to do because this hash must look a certain way and fall below a certain value. A piece of arbitrary data is added to the block called a nonce, which alters the hash. Once a node produces the correct hash, it broadcasts it to the rest of the network. That node is then rewarded with new Bitcoin. The current block is then time-stamped and added to the chain, and its header's hash is stored in the next block's header. In this way, all the blocks are linked together. It is not possible to alter any earlier block without altering every subsequent block and redoing all the work required to produce each block all over again. Blockchain is often divided between permissionless and permissioned distributed ledgers. Model 1 shows the current systems where transactions are reconciled with a central electronic ledger. Model 2 shows a public blockchain or a permissionless distributed ledger. A public blockchain is an open network that anybody can access. It is open to all, and transactions can take place between parties that neither know nor trust each other. Transactions are verified cryptographically by users on the network. The Bitcoin blockchain is a good example of a public blockchain. Users are rewarded with new Bitcoin every time they verify a new block of transactions. This is known as mining. By contrast, Model 3 shows a private blockchain or a permissioned distributed ledger. These are private and the participants will know each other. Transactions are still verified and collected into blocks, but this kind of ledger is governed by rules agreed in advance by the participating parties and does not rely on mining.